To summarize everything we went over in class today, let's talk about the steps for analyzing the graph of a polynomial function. The first thing you'll want to do is determine the end behavior. Of the graph. And remember, there are two things you need to look at to determine the end behavior. One is the degree of the polynomial, and the second is the sign of the leading coefficient. The next thing you can do is find the x and y intercepts. Of the graph of the function. Those are good points to be able to determine the shape of the graph. The third thing you'll want to do is determine the zeros of the function, which remember are the x-intercepts, and their multiplicity. So you're going to use this information to determine whether the graph actually crosses or bounces off the x-axis. At each x-intercept. You can also determine the number of maximum turning points. This just helps make sure that the graph is as accurate as it can be. And then you'll use these steps to draw a complete graph of the function. So let's work an example. In example 6, we have the function h of x is equal to negative 3x squared times x plus 1 squared times x minus 1. Now remember in class we talked about this polynomial is already factored, and we want to leave it in factored form because we are going to have to find the x-intercepts, which means we will need it to be factored to do that. However, we also need to know the leading term and the degree of the polynomial. So to determine that, what you'll want to do is you'll want to just look at the term of the first term in each set of parentheses and the power that it's raised to. So the leading term can be determined not by multiplying everything out, but just by multiplying these things together. So we have a negative 3x squared to start with, times, and then this is going to give us an x squared because this binomial is squared. And then this will just give us an x because there is no power out here. So if we multiply those together, that's going to give us negative 3 x squared times x squared is x to the 4th times another x will give you x to the 5th. So this is an odd degree polynomial, which means the ends will go in opposite direction, and the leading coefficient is negative, which means it will be a decreasing function. So opposite directions and a decreasing function. So the end behavior is going to start high and go low. So that was step 1. Step 2 then is to find the x and y intercepts. I'm going to start with the y-intercepts because the x-intercepts are going to lead us into step 3. So remember, we've learned how to do this. To find the y-intercept, you're going to let x equal 0. So that means we're finding h of 0. So I'll have negative 3 times 0 squared times 0 plus 1 squared times 0 minus 1. Well, that's negative 3. 0 squared is just 0. This is 1 squared, which will just be 1. and this is -1. But -3 times 0 is 0, and 0 times anything else will give you 0. So that means the y-intercept is 0, which means the graph is going to go through the origin. Now, step 3 tells, well, I'm going to combine step 2 and 3 together because step 2 also says the x-intercepts, which, remember, we talked in class about. Those are also the zeros of the function. And so to do that, what we're going to do is set the whole function equal to 0. Sorry, that got off there. There we go. All right, so I'm going to take this -3x squared times x plus 1 squared times x minus 1. And I'm going to set that equal to 0. So that's going to give me -3 times x times x times x plus 1 times x plus 1 times x minus 1 equals 0. So if I expand those exponents, that's what I'm given. And now you can see x times x times x times x times x will give you x to the 5th. All right, so I could set this -3 equal to 0, but that's just kind of nonsense. That's not going to help us. But then I have x equals 0 twice. I have x equals, well, let me go ahead and say x plus 1 equals 0 twice. And then you also have x minus 1 equals 0. So I'm going to get 0 for one of my zeros here. I'm going to get x equals -1 for both of these. And then x equals 1 for this one. So this has a multiplicity of 2. This one has a multiplicity of 2 because it's a 0 twice. And this one has a multiplicity of 1. Sorry, guys. So that's going to help me know how the graph behaves at those x-intercepts. And the fourth thing was to determine the maximum number of turning points. And remember that that is 1 less than the degree. So since the degree is 5, it's going to be 5 minus 1, or 4. Now remember, that's the maximum number. It may not turn that many times, but let's see. All right, so what the points we can plot are x and y intercepts. So I'm going to go ahead and do that. So I had 0, 0. I had -1 and 1. I also know the end behavior. So I know that since this is the last time it's going to touch the x-axis over here, whoops, I think this one went from down to up. Yeah, so it's going to come up here. And since I know it's only going to touch the x-axis and these 3 points, this is the end point for this side, and it's going to come down from here. Now I know that at -1, since the multiplicity is 2, it's going to bounce at both of these, and then it's going to cross because 1 is an odd multiplicity at 1. So it's going to bounce off at -1. It's going to bounce off at 0, but then it's going to cross at 1. So that is the graph of this polynomial. And we'll see, let's see, it has 1, 2, 3, 4 turning points, but only 3 x-intercepts. but 5 solutions because 0 and -1 were a solution twice.